Hello, 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 everybody. Root Beer here, looking at question B2 on our 2017 Canadian Senior Math Contest. Okay. Joe plays a game using some cards, each of which is red on one side and green on the other. To begin the game, Joe selects integers k and n, where k is strictly less than n, but they're both positive integers. He then lays n cards on the table in a row with the red faces all turned up. Looks like we've got a sample game being played over here. On each turn, Joe flips over exactly k of the n cards. Okay, no more, no less. Joe wins the game if, after an integer number of turns, so not halfway through a turn or anything like that, he has flipped other cards so that each card now has the green side facing up. For example, when you start with 4 cards and you're allowed to flip exactly 3 at a time, Joe can win the game in 4 turns. So first he flips these 3. Then he flips this one from red to green and these 2 from green to red. I guess I should do that. And then so he's reached sort of a halfway point where he's got 2 green, 2 red. And then I guess he could just undo that a little bit. Flips these 2 green and this one, this red. And then finally flips these 3 reds. Okay. So what have we got? 3 parts here. A, B, C. A, when n equals 6 and k equals 4, show that Joe can win the game in 3 turns. Okay? So, by the way, this is a game theory style question. They have presented a game for us. We might start thinking about winning, losing, strategies, those sorts of things. So we're going to try and win in 3 turns with 6 and 4. We could probably just play around and manage to work that out. B, when n is 9 and you can flip 5 at a time, show that Joe can win, but they're not saying you have to do it in a certain amount of terms. We just need to explain why Joe can win, or how Joe can win. And while we're reading these, let's look at C. Suppose we've got 2017 cards, the year of the contest. Determine with justification all K, for which Joe cannot win the game. Okay, so we want him not to win. That's different from the first 2. So, as we do A and B, let's take lessons on how we're winning, what strategies we're employing. Because part of being able to, because it's a written question, so we got to do justification. Part of being able to justify is being able to say, all right, in C, these Ks all can let him win, and we probably do say a quick strategy based on what we've learned in A and B, and these Ks can't win for some observation, some nice universal reason. Okay, let's just get into it with A. So we got 6 cards, start with reds. Now I know we have to show our work, but it really is enough to get marks on A part to just show what exactly it is that we're doing. Okay. Now one thing I might try is, I noticed up here, after we reached a halfway point where we had an equal number of G's and R's, and then we just sort of undid what we saw there. So that might be something to try. Well, we got to flip 4 of them to be green, so I mean that's got to be the first move. You can't do anything else other than when you have 4 reds. And since they want us to win in a certain number of turns, let's say that's turn 1. Okay. Now we'll have to have turn 2. Give myself a little bit more space. And then turn 3 is when we need to have all greens. Okay? Because they won in 4 turns in the example, so we need to win in 3 turns. So, what can we do? If I'm going to win here, then my previous turn had to have something like 4 reds. Not necessarily these 4 reds, but I needed to have 4 reds kicking around. Okay? Which means on this turn, I need to find a way to get some reds. Now, if you flip a red, it turns into a green. I've already got 2 reds. Can I just leave them as is? No, because if I don't flip those cards, I'm just flipping these greens back. Okay, so we can start to reason that way. You're welcome to explain that, but that's not what's required for this part of the question. So I got to flip some of these reds. What if I flip both of them? Flip them both to greens. Well, then I've got my greens here, and then so the reds would have to be here. Well, you've already flipped these two. You can't flip these all again. That'd be flipping all 6 cards. So, can't flip those. What if I left one and I flipped another one? Okay? So I flipped one card. I need to flip 3 more. 3 of these G's, flip them to R's, leaves 1 G left, and then my last turn. And so something you can do is you can say, all right, I'm flipping these, then I'm, flipping these, and then finally we're flipping these. Now that's kind of interesting, just highlighting it like that. You'll notice that these, the first 3, this is just my observation, these first 3 get flipped a whole lot, and then one at a time, we're flipping one of the others. That's kind of interesting. So I wonder if we could employ a similar strategy in B, or will it not work for, what was it, 9 and 5? N equals 9, flipping 5 at a time, and we might have to do something else. But there we go, we managed to do it in 3 turns. We talked our way through it. You could, of course, write down some of what I said, but I don't think it's entirely necessary. Okay, now, it's not going to be, we're not given a particular number of turns we have to use, so this could be a lot looser, a lot flimsier. Let's say we flip these here. Then I'm going to flip these ones again, but we'll flip this one. So I think flipping these all one at a time just constantly flipping these 4 back and forth and changing one of the other ones. I'm gonna suspect this might work. This might not be the best strategy, but if it works, so be it. Yeah, and then we'll have just enough R's at the end. So there we go. And again, I'm gonna just highlight what I did. I flipped these 5, then these 4 in this one, and these 4. It's just these 4 all the time, and then an additional one each time. So that's pretty interesting. That might give us a strategy. So this is N is 9, K is 5. That might help us with a strategy for C part, because now we are at C, and we need to sort of look at, all right, what can you do, what can't you do? If I use one card at a time, can we win? And I would say it's pretty clear that you can always win if you use one card at a time. Just flip each single card. Can I win with 2? If I've got 2017, if I flip 2 at a time, can I win? And we might want to start with little investigations like that. But it's also important to realize what sort of answer we would be looking for in C. Okay? So just, while we're talking here, strategies for game theory questions like this. So a correct answer for C looks like this. These K work. These K will get us to flip. And here's my strategy. Or for a more complicated question, there might be multiple strategies. Like maybe something works for most Ks, but for perfect squares, you have to do something extra. Okay? So you want to say these K work, and here's a strategy. And then you'll want to say these K don't. And here's proof why there can never be a strategy. Because just because your strategy above doesn't apply to these particular other Ks, doesn't mean any old strategy. Just because you can't find a strategy doesn't mean there isn't one. Just maybe you didn't look hard enough. So the way you tend to handle a proof is you find something that is true as you're, I guess, flipping the cards in this case, but true about this K or the N that you start with that makes it so there's no way to achieve the desired result. Usually something you would look for is proof's probably going to be based on invariance. Looks for things that don't change. Yeah, we're flipping cards, And a strategy for flipping cards can do any number of things. You can't account for all of them, but you look for something that doesn't change no matter how you flip the cards. That's a good thing to look for. Okay? And that can be, something as simple as like parity, like oddness, evenness, something a bit more exotic, like being congruent to 7 modulo um, 19, or, could have to do with number of factors, something like that. Uh, things that just don't change overall. That's what we're on the hunt for when we do that. Okay. So I guess what we might want to do is look at simpler cases. Now, this is a fantastic way to do things because, I can't play with 2017 of these cards all at once. But what we could do is we could look at smaller cases. We already have. We looked at 9 and 5 in the last one, 6 and 4 in the first one. But we want to try and capture what it is that 17 has to offer. Or sorry, 2017 has to offer. So what are some special things about this? It's prime. It's odd. It's not a perfect square or anything like that. Nothing else that I can see. But those two things come to mind. But it's a good idea just when you're writing a contest. When if you're writing in the year 2030 or something like that, it's a good idea to be able to walk into that contest knowing, all right, I know the factors of this number. I know if it's prime. I know, interesting features of this number. It's a sum of 2 squares, that sort of stuff. So because it can help you with something like this. Odd, I'm going to guess, might be somewhat important. Prime's good. Why don't we look at just having 3 cards? Okay. Let's answer this question with 3 cards. There's only really 2 cases to work with. K is 1, which we already know works, and K is 2. So let's start with 3 R's and see, can I get all G's? Or is there a reason that I can't? Okay, so we could, you got to flip 2 of them, G's and an R. Okay, now in the end, I'm going to want some G's. And, all right, so what's going to happen next? Well, I don't want to flip these 2 G's again. We just flipped them. That would be taking me back a step. So I got to flip this. Okay, but I got to flip at least something else. So one of these is going to turn into an R, and I'll be left with 2 G's. And that's basically what we just saw. So, you don't want to flip these again, so you're going to have to flip this one. So it'll have to turn into an R, otherwise you go back a step. And then you flip one of these. If you flip the G, you're stuck with 2 R's. If you flip the R, you still have 2 G's. So really, what we can notice is no matter what, I seem to always have an odd number of R's. Okay? This, parity tends to be a pretty common invariant. So you're always going to have an odd number of R's if you flip 2 at once. But can I develop this a little bit more? Can I sort of, is there something special about 2, or is it something special about the 3 that we start with? And can I turn it into a more grand statement than just saying, well, I played around with it. I notice you always have an odd number of R's. Okay? What can we do here? Well, I think before I get into that, I'd like to experiment with something else. Maybe say n is 5. 5 is odd. It's also a prime. So those 2 things I noticed about 2017 are coming into play. Although my observation here makes me think it's the oddness that matters, probably not the primeness. But on a different question, on a different contest, maybe the fact that 2017 is prime would have mattered. So now, let's try it with k equals 2. Okay, we know k equals 1 would work. Notice that we're still getting an odd number of R's. Now, what could I do next? I don't want to flip these 2. Maybe flip 2 more of the R's. Still have an odd number of R's. Well, maybe I could flip a G and an R. Still an odd number of R's. And if we can find a way to formalize this, really explain why it'll always be an odd number of R's, no matter what you do, then we can realize, well, you'll never get all G's because that would be 0 R's. Okay? Now that was with 2. What about 3? So if we flip 3 of them, you'll notice we've got an even number of R's here. Now, if I do it again, maybe... Actually, we could try and follow my general strategy. So let's flip the first 2, and we'll change another one of these. And then we're left with 3 R's at the end. So when n is 3, k equals 1 worked, k equals 2 did not. So far, n equals 5, k equals 1 works, k equals 2 does not, k equals 3 does. And the 2 doesn't work because I'm noticing an oddness with the R's is always maintained. That's kind of invariant. Let's try with the only other possibility, k equals 4. We'll get a fresh sheet of paper for that. It deserves it. So let's try flipping 4 cards at once and see what happens. So let's... There we go. You'll notice we went from 5 R's to 1 R. Interesting, interesting. Okay. But now, what can we do? Well, can't flip these G's again. We got to flip this R. Otherwise, we're just going back to the previous step, or the previous situation. So I got to flip that, and then I'm going to have to flip 3 of the G's. So I'll get 3 R's, and the 1 G left over stays as a G. So you still get an odd number of R's. Now, why is this happening? Okay, so let's suppose we have, actually, because this is going to turn into, I believe, a solution here. So, here's my claim. We claim for 2017, just based on our work with 3 and 5. If we wanted to do more with 7 or 9, we could keep going. But if k is even, we cannot win. So we'll have to prove why that can't work. And with k is odd, we can win. So we'll have to provide a useful strategy for that. So my strategy so far is flip the first so many and then flip another one each time. And it should always work. Okay. So let's start with if k is even. So we claim there will always be an odd number of reds. You can just say R's, because I mean that's what they did in the question. They used R's and G's. Okay. They will claim there will be an odd number of R's. And so we cannot, by conclusion, the conclusion is we cannot get 2017 G's and 0 R's to win. Okay. So how do I prove that? Well, we know we start with 2017 R's. We start with an odd number of R's. Okay. Now, suppose after, let's say, turn T, we have G greens. Actually, G greens and R reds with R odd. So, actually, I guess the best thing to do would be to say, all right, 2R plus 1 reds. In fact, so I want to guarantee that this is odd, so we'll say 2R plus 1 reds. And we don't need G greens, I guess. We can just say 2017 minus that many greens. But you'll notice it's an even number of greens and odd number of reds. Okay. So if we select, now I'm trying to think about my next line. So let's say, suppose we select G greens to flip. And so K minus G red cards to flip. If G is even, Then we have G new reds and G less greens. But K minus G less reds, because we flipped that many reds, and K minus G more greens. Okay. So if G is even, we don't even need, I don't think we need G is even. Let's just say, then we have G new reds, G less greens. So the number of reds was 2R plus 1. We lost K minus G of them, but we gained G of them because we took G green cards and turned them into red cards. That's 2R plus 1 minus K minus minus, so plus we'll have 2 Gs. This is odd since K is even. Okay? 2R, 2G, that's even. K is even. Sum of even numbers is even. And then you add 1, it's odd. So we'll still get an odd number of reds. If you care, not that you would need this, the number of greens changes by an even amount as well, obviously. 2016 minus 2R. We gain K minus G greens, but we lose G greens. So this is still even, but also because K is even. Okay. So if you have on your turn an odd number of reds, then no matter how many greens you choose to flip, because you're flipping an even number of cards, you will still get an odd number of reds. We start with an odd number of reds, so we will always have an odd number of reds, and you cannot win. Okay? So that's why that shows that if you have an even number of cards being flipped at a time, you can't win. But now we have to show something that might be a little harder. If K is odd, we have to show that you can win. So I claim my strategy. And there are probably more elegant strategies, but this is one that I thought just sort of popped out quite quickly from what I had done earlier in A and B. So my claim, my strategy works as follows. Okay. If I let K be something like 2S plus 1, because K is odd, flip the first 2S cards. Oh, let's say something like this. Let's say let's let. Okay. So number the cards 1, 2, up to 2017. On turn T, flip cards 1, 2, all the way up to 2S. And also card 2S plus T. Then we claim after 2017 minus 2S turns, we will be done. Okay? Perfectly good strategy, but I gotta explain to them why this is going to work. So let's go through each card and explain why I know it'll be green. Each card, 2S plus 1, 2S plus 2, up to 2017, is flipped only once. So they go from red to green, and that's it. And on turn 1, the card 2s plus 1 flips, it's green, and we never touch it again. On the second turn, the 2s plus 2 flips from red to green, and we never touch it again. And then on our last turn, 2017 minus 2s, that last card will flip from red to green. Okay? Now, what about those first cards? Well, since we flip each of cards 1, 2, all the way up to 2s each turn, it is easy to see after odd turns, all of them will be green. So on the first turn, they all go from red to green, but then on the next turn, they'll all go from green to red. And after even turns, all of them will be red. Okay? So now it's just a quick question of, well, how many turns? The number of turns is 2017 minus 2s. That's how you get the last card here done. Okay? Which is odd, because it's an odd number minus an even number. So after the 2017 minus 2s turn, the cards 1 through 2s are red as desired. There we go. Got a nice little strategy. This clearly works based on what we saw, observed when we were playing around with it. And it's a very good idea for a question like this to just sort of play around with simpler cases before jumping straight to the 2017. Okay, so very nice little strategy there. So you got to show off a strategy, explain why it works, and here we used an invariance. I don't know exactly what you're going to do with the cards. Anyone could do anything with the cards, but I know that if k is even, the oddness and evenness of the reds doesn't change it. It starts odd, so it'll always be odd. You'll never get 0 reds, because of course 0 is an even number. All right, so that does it for B2. We've got one more question to go on the paper, and that's going to be B3. I will see you for that in the following video.